In this video, we're going to look at how you go about creating a stratified or representative sample of a larger group of data. We'll look at plotting data points and creating a line of best fit on a scatter graph, and then we'll look at how to recognize and label a correlation and some of the assumptions that can be made from it. Here, we're asked to create a stratified sample of 60 students to represent this entire cohort. We have 88 students doing motor vehicle courses, 120 doing construction, 74 doing hair and beauty courses, 60 doing health and social care courses, and 45 completing courses in hospitality. In order to make this sample of 60 representative, it should consist of the same proportions as the courses do in the entire cohort. So we need to find each amount as a fraction of the total amount. If we add them up, we can find that there's 387 students in total. So we can put all the individual course totals as fractions over this. Now we can use those fractions to calculate how many we will need from each group to make up our sample of 60. So we're going to multiply 60 by each of those fractions, which will mean that we'll get for motor vehicle 13.6 students, for construction 18.6, for the hair and beauty courses we'll get 11.5, for the health and social care 9.3, and for hospitality 6.97. Now obviously you can't have 0.6 or 0.5, in fact any decimal of a person, so we need to round these to the nearest whole number. So I'll do that now. So let's round the motor vehicle students to 14, the construction students to 19, 12 for the hair and beauty students, 9 for the health and social care students, and 7 for hospitality. However, if we add these up, we find that we have 61 students. So I've rounded the hair and beauty ones down to 11, as this was the lowest number that was rounded up. So now we've got our sample size that's representative of this entire cohort of students. And we can check by adding it to get 14 plus 19 plus 11 plus 9 plus 7 equals 60. We can say that we have a representative sample, or a stratified sample of 60 students to represent the larger student body. Now, let's look at how we'd create a scatter graph to represent data in order to see if there's a relationship between two variables. Here we have a scatter graph which shows how students did on a test, together with how many hours they revised for it. The test scores go from 0 to 100% on the y-axis, going vertically up, and hours revised is on the x-axis, going horizontally. Firstly, we're asked to plot the remaining 3 points that are given to the right of the graph. We can plot these by following straight up from 6 hours spent revising up to the test score of 55 and place an X there. We can go from 7 up to 82 and place an X there. And we'll go from 8 up to 73 and place an X there. That plots all the remaining points. Now we're asked to describe the relationship between the test scores and the time spent revising. We can draw what is called a line of best fit here, which is a straight line that goes through the middle of the data, trying to keep points as close as possible to it, with as many above as below the line, and the distance from the line equal to as many points as possible. This isn't too difficult, as there tends to be a correlation between this data, between the time spent revising and the test scores. On the whole, as the students spent more time revising, their scores increased. So we can state that as the relationship, or simply that there is a positive correlation. The word correlation means that we suspect there's a relationship, and further investigation would be needed to prove that as a cause. We can now use this line of best fit to answer the next question, which is to predict how well someone would do if they revised for 8 hours. We'll draw a line up from 8 hours to the line of best fit, and then across to the test score to get roughly 82 or 83. There's always going to be an allowance or a margin of error for this type of question due to the estimation of the line of best fit. Next, we're asked if there's any unusual data points. And if we look up from the 1 hour part, we can find someone who scored almost 90% after only revising for 1 hour. There could be many reasons for this. They may be extremely good at the subject. They may have cheated. They may have misunderstood the question when being asked how long they spent revising. More investigation is needed, but we can certainly state that this data point is an outlier. The last part of the question is whether we can use this to predict how someone who studied for 20 hours would do. As the data only goes up to 9 hours worth of study, it's well beyond what the data set encompasses. There's a general rule that you can't go beyond 10% of what the data set includes. So whilst you could possibly predict for someone who studied for 10 hours, studying for 20 hours goes beyond the bounds of the data set, and it's too far for it to be accurate. So if the line of best fit continued, it would seem that they'd score more than 100%, which isn't possible. Next, we'll look more closely at lines of best fit and how the correlation can be described. In this question, the first graph we can see, there's a scattering of data, but the trend seems to be for a positive correlation, as the line of best fit heads upwards. Although the data is quite far from the line, there seems to be a suggestion of a weak positive relationship between these two data sets, and therefore we can say it has a weak positive correlation. On the second graph, there doesn't seem to be any grouping in any direction to suggest what kind of correlation there would be. Therefore, we can state that there doesn't seem to be a correlation between these two sets of data. In the third graph, we seem to have a tight grouping around a line of best fit, and we could state that there's a strong negative correlation between these two data sets. If you were to go on to study statistics A-level, you'd be looking at how to draw what's called a line of regression, which is a mathematical calculation for where this line would be. But at GCSE level, we look to roughly estimate it, and it's called a line of best fit. In this video, we looked at how to go about creating a stratified or representative sample of a larger population of data. We looked at plotting data points and creating a line of best fit, and then we looked at recognizing correlations and some of the assumptions that can be made from them. In the next video, we'll be looking at cumulative frequency graphs and histograms. I'll see you then.